In this video, we'll move from what an atom is to calculations you need to know in an atom. So stay with me. We'll move from what an atom is to calculations you need to know in an atom.
Electronic configuration, because once you know atomic structure, you can solve a lot of questions with just knowing your atomic structure. So that's why I love starting with what an atom is. And once you understand what an atom is, once you understand the structure of an atom, majority of our chemistry rises and falls on atoms. So basically, we know what an atom is. We say the word. An atom is the smallest particle of an element. It's the smallest particle of an element that can take part in a chemical reaction. So it is the smallest particle of an element that can take part in a chemical reaction. And what that means is that we have other small particles, but those ones can take part in a chemical reaction. So that will now lead us to what we call the subatomic particles. So we have what we call the subatomic particles. So the word sub here means under or smaller. So it is under atomic particles or smaller than. So subatomic particles. So under atoms. So what are these subatomic particles? Basically, there are 3 of them, the subatomic particles. We have the what? Protons. We have the neutrons, and we have the what? We have the electrons. So we have your protons, we have your neutrons, and we have your electrons. So there are 2 things you need to know about your protons, your neutrons, and electrons. You should know their charge. So what is the charge of these subatomic particles? For protons, it is +1 or 1 plus, whatever you call it. So 1, it is positively charged. So positive. Neutrons are neutral. So just use the word neutral, neutrons to remember it. So the charge is 0, and electrons are negatively charged. 1 negative. So 1. Then for the next thing you want to know about them is their mass. So the mass of protons is 1. Your mass of proton is 1. Your relative mass is not just, it's a relative mass, not just the mass of it. So they are so small that they couldn't get the exact mass, so they call the relative mass in relation to other particles. Then sorry about that. Then your mass of neutrons is also 1. Then the mass of electrons is 1/1840, which is equivalent to 0.0054. 0.0054. So you can see that it is so small, so most times it is negligible. So when we are adding, that is why you see that the mass of an atom, what contributes to the mass of an atom, what we'll be seeing as we move on, the mass number is just what the number of protons and the number of neutrons. The number of electrons does not add because it is negligible, so we call this negligible. So it is too small, you can neglect it, so you can just neglect it. That is what negligible is. So having understood that, okay, we have an atom, then we have subatomic particles. We say an atom is the smallest part of an element that can take part in a chemical reaction, and in that atom there are other particles we call it subatomic particles. So now let's look at what the structure of an atom is. That's why I call it atomic structure. So for an atom we have, so let's structure of an atom. So for an atom we have the shell, then we have the nucleus. So this is your nucleus, there are particles inside. Then this is your shell. So you have various shells. Let me just draw one shell. So your atoms, some have one shell, some have two shells, some have three shells, and we'll look at it as we go on. So these two, for now, this is your shell, the shell of an atom. So that is your shell. Then this center part is your nucleus. So anywhere you hear nucleus in this life, you should always think of the center of something. For example, the center of your cell, if you're a biology student, is your what? Is your nucleus. So nucleus has to do with center. So basically, we have the nucleus and the shell. Next, we want to ask ourselves, why is this information important? Why do we have to know, okay, there's a shell and there's a nucleus? To know the particles that are found in them. So we want to know what subatomic particles. So we say subatomic, so they are under atomic, so they are inside the atom. So subatomic particles. So what are the subatomic particles found in your shell? So for your shell, your electrons are found here. Your electrons are found in your shell. So let's go next. The electrons. Why? For your nucleus, what's found here? The photons and neutrons. The photons and neutrons are found in your nucleus, while on the shell is the what? Is the electrons. So let's start with this basic information. As we go on, we get to understand more. So you should know that your electrons are found in your shell, and in your shell we have what we call subshells, and in those subshells we have what we call orbitals. So an orbital is the most likely place an electron will be found in the shell. So the shell is like that big place. The shell is like the house itself. But me, if I'm at home, where you find me most times is not in the kitchen. You find me in my room. So the place where you most likely found me is my orbital. So my room is my orbital. So basically, as we go on, we unravel these things. So let's move on. So let's look at the shell, for instance. We already know what the nucleus contains your protons and your neutrons, and this is the atomic structure. Basically, your neutrons and protons and your nucleus and electrons are in the shell. You start electrons are negatively charged, protons are positively charged, and neutrons are neutral. You start the electron, the mass of electron is negligible, 0.000544, and the mass of protons and neutrons for 1. So having said that, let's look at what a shell and what the importance of knowing this shell. So if you look at your periodic table, let me bring one quickly. If you look at your periodic table, this is your first 20 elements. I love working with first 20 elements. Once you grab first 20 elements, the other ones comes easy. So you have hydrogen down to calcium. And there is a law that these elements are not just arranged anyhow, randomly. No, they are arranged in order of what? Increasing atomic mass. Sorry, in order of increasing atomic number. So they are arranged in order of increasing atomic number. So what that means is that is why hydrogen is the first, because it has atomic number 1. Helium is the second, and so on. So what does atomic number mean? What does atomic number mean? So let's know what it means. Basically, atomic number, if you have an element like this, X, if you have an element X and we have, let's say, A, Z. So this is just a representation of an ideal element. Or so basically, A here is your mass number. Mass number. Z is the atomic number. And X itself is the atom of an element. So it's the element. So the knowledge of electrons, protons, and neutrons will help us to understand mass number, atomic number, and element. So what is the, let's start with atomic number. What is atomic number? So say atomic number is the number of protons in an element, as simple as that. So number 1, we have atomic number. It is the number of elements is the number of protons in an atom of an element. So when we say elements are arranged in order of increasing atomic number, we are saying elements are arranged in order of increasing number of protons in them. That is to say, hydrogen 1, which is the first element, has 1 proton. Helium has 2 protons. Lithium has 3 protons. Barium has 4 protons. Boron has 5 protons, and so on and so forth. So basically, that is atomic number. Then the next is what? Mass number. Mass number. So we see mass number A. This one is Z. So let's continue. We said atomic number is what? Number of protons in an atom of an element, while mass number A is the sum of the number of protons, that is the sum of the atomic number, the sum of the number protons in brackets the atomic number is the sum of the number of protons and the number of neutrons, and the number of neutrons in an atom of an element. So basically these are the definitions you must know, and you can represent them mathematically. So say atomic number Z is equal to number of protons. And we said mass number A is equal to number of protons or atomic number, so number of protons plus number of neutrons. So basically let's see a use case. Let's look at one example. So for example, they can give you a table. So we have an example.
Why are you talking like that?
So we have an atom.
Why are you talking like that?
We have an atom. We have mass number. So mass number. We have number of protons. And we have number of neutrons. So they can ask you to, they can just give you the atom and tell you to find the mass number, the number of protons, and the number of neutrons. They can still have number of electrons, but we are getting there. Now I've not mentioned anything about electrons so far. So I will make one statement that will connect the dots together basically. So in this case, the atoms are, we have 14 x 6. So therefore our mass number is what? 14. So I'm already giving you the answer, so it's as easy as that. Then the next we have 38, 19. So if you remember from what we said earlier, let's move up. We said what an element is presented like this here. So we have what A as your what mass number, Z as the atomic number, and X as the element. So this is how they represent an atom, showing the atomic number, the mass number, and the element. So let's come back. So you can see a similar representation here. So X is an element. They will just give you X, Y, Z, and it does not mean there is an element like X. It does not mean there is an element like Y. But it is saying that is just a representation. It's like saying your equation, algebraic equation, x plus y is equal to 5, find x. So they can give you something like this, and when you are done, they can tell you, okay, what element is actually this x. You now, from your knowledge of the periodic table, you now ask yourself, in this case, what element is the number 6 on the periodic table, and that is carbon. So these are questions come out. So let's see, what is the mass number here? We all agree that it is what? 14, because say mass number is represented as the number up here. So 14. What is the number of protons? Say this down here is Z. Z is equals to 6, and Z is what? Number of protons. That atomic number is the number of protons. So we come here to write 6 as the what? Atomic number 6. Then number of newtons. So for the number of newtons, we have already established that your mass number is equal to your what? We said your mass number A is equal to number of protons plus number of what? Newtons. And here our already not. So we say number of protons P plus number of newtons. So for that first one, we already know what our A is. So let's just say where our A is what? A is equal to 14. That's our mass number is 14. We already know that. Our mass number is 14. Then what is our P? We already know that our number of protons is what? 6. So now we are looking for what? For our N, number of newtons. So now say 14 is equal to what? 14 is equal to 6 plus N. Therefore, N is equal to what? 14 minus 6, which is equal to what? 8. So our number of newtons is what? Is 8. Hope you understood this. So is that easy? Yeah, is that easy? So a faster way to find a number of newtons, you just do 14 minus 6 here. So 14 minus 6. So 14 is your what? You already know is your atomic number. 6 is your number of protons. So 14 minus 6 will give you what? Your number of newtons. So let's do the second one quickly. What is our mass number? 38. What is our number of protons? The same thing as our atomic number, so it is 19. And lastly, what is our number of newtons? 38 minus 19, it is also what? 19. So basically, this is our answer. This is our answer. So we will see other examples as we move on, but quickly let's look at the role electrons have to play here. Let's look at the role electrons have to play. So sometimes they can ask you, they can give you another column and tell you what is the number of electrons. So like I said, I will give you one statement that will change everything. So note in a neutral atom of an element, in a neutral atom of an element. The number of photons. The number of photons is equal to the number of electrons. In a neutral atom of an element, the number of protons is equal to the number of electrons. So that is to say that P is equal to E. So protons equal to electrons. So you should notice this is a very important thing to take note of. So take note, the word here is neutral. In a neutral atom, the word here is neutral atom, because you see there are what we call ions. As we move on, you see ions, but in a neutral atom of an element, the number of protons is equal to the number of electrons. So before we go on, let's quickly recap all we have done. It has an atom is what? Is the smallest particle of an element. The word here is smallest particle of an element that can take part in a chemical reaction. So your protons can take part in a chemical reaction, though they are smaller than an atom. So that can take part in what? A chemical reaction. So smallest particle of an element that can take part in a chemical reaction. Those are your two keywords that must be in your definition. You start for your atom, we have what we call the subatomic particle. Sub meaning under. So sub, for example, sub-zero, below zero, and below zero is what? Is ice. That's why sub-zero shoots out ice. Yes. So that's just on the side. Subatomic. Sub meaning under, atomic meaning your atom. So subatomic particles. And what are subatomic particles? We said they are what? Protons, neutrons, and electrons. So you can use the mnemonic pen in case you are just new to this, but I believe none of us are new to this. So we have pen, protons, electrons, and neutrons. I've said the things you want to know about these subatomic particles are their charge. What is the charge of protons? Protons are positive, electrons are negative, neutrons are neutral. What is the mass? The mass is what? 1 for protons, 1 for neutrons, and 0.000544 for electrons. That's why you see that all our calculations so far, we have not mentioned electrons, because electrons don't contribute to the mass number. They are negligible. So that's it. Then we'll move on to talk about the structure of an atom. And for the structure, we see we have the shell, that is the guys that have the electrons, and we have the nucleus. The nucleus is the central part. So the nucleus is the what? Is the central part. Here is your nucleus. Then we move on to the nucleus has your protons and neutrons. Then move on to what a mass number is, what an atomic number is, and what the the elements are, and this is your first 20 elements on the periodic table. I believe we all know it by now. If you don't, you should climb it. There is a song I use: hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, chlorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. So once you listen to this song over and over again, you should get your first 20 elements. Then next we define what atomic number is. We say atomic number Z. Atomic number Z is the number of protons in an atom of an element. Then we said mass number A is the sum of the number of protons and the number of neutrons in an atom of an element. Then we'll move on to see some calculations. And lastly, we said that you should take note that in a neutral atom of an element, the number of protons is equal to the number of electrons. So, having said that, let's look at some quick example. So we have, if an atom so example 2, let's call this example 1. Example 2. If an atom of an element represented as x 20. This shows that it has, so these are A, 40 newtons, B, mass number of 20, C, 20 protons, and D, atomic number of 40. So what is the answer? Atomic number of 40. So 40, 20. So what can we say from this? Is it that there are 40 newtons? Exactly, that's no, because we say this 40 is sum of what? Number of newtons and number of protons. Mass number of 20? No, this 20 is what? Is the atomic number, which is your number of protons. 20 protons, yes. So this is our answer. 20 protons. Atomic number of 40? No. atomic number is the number of protons, which is 20. So that way we know the answer already. So it's as easy as that. Let's just find the number of protons. So from here we know that number of protons P is equal to what? 20. Then what will be your number of electrons? Now let's come back to this statement. We say what? In a neutral atom of an element, the number of protons is equal to the number of electrons. So this is a neutral atom of an element. So the number of protons will be what? Equal to the number of electrons. So our number of electrons here is also what? 20. Then our number of neutrons is what? I say your mass number minus your atomic number. So 40 minus 20, which is also 20. So that is it. So let's move on to the next. So having said that, you can look at let's look at the number of protons and number of electrons when it is not a neutral atom. So now we have seen for that of a neutral atom, let's look at what we call ions.